here, we'll solve the equation log base 6 of the number x minus 1 plus log base 6 of the number x minus 2 equals 1. We can't directly translate at this point because we have two logs on one side, a number on the other side. So first, let's call this step 1. Use laws of logs to combine the two logs. So we're going to combine them and make a single log. Then we'll translate. Okay, so we have that rule. It's rule, I believe, number 5 in the note that we saw earlier. So it will take the log of A plus the log of B and write it as a single log of A times B. So this is log base 6 of the first x minus 1 times the second x minus 2. Parentheses bracket, bring down the equal sign, bring down the 1. Now step 2, we're ready, since we have a single log equal to a number, we're ready to translate into exponential form. See, the problem here is the variable that we're trying to solve for is locked up inside of the number part of the log. We're going to try to get it out by translating. So use the butterfly, base 6 to the exponent 1 equals a number, x minus 1 times x minus 2. So we have 6 to the first power is equal to x minus 1 times x minus 2. Okay, so that means that 6 is equal to x squared, product of the outers plus product of the inners is negative 3x, last times last is positive 2. Move the 6 over because this is a second degree equation. We want to solve by moving everything to one side, setting and factoring the non-zero side. These guys cancel, you get 0 equals x squared minus 3x. 2 minus 6 is negative 4. So let's see, are we going to be able to factor this? We'll have to, I think we can factor this as x minus 4 times x plus 3. Let's try that. Product of the outers plus product of the inners, 3x minus 4x. Nope, that doesn't work. Yeah, the problem is this dude. He should be 1, not 3. He should be 1. Let's try it now. Product of the outers plus product of the inners. The outers is 1x, minus 4x is negative 3x. Last times last, negative 4 times 1 is negative 4. That's good. That gives us two solutions. That gives us x equals positive 4, union together with x equals negative 1. Now I'd like to put a box around both of these answers, but the fact is that x, go back to the original question at the very top. X was involved in the number part of the log, and we know the number part, the part that the log is acting on, has to be greater than 0. Negative 1 is not greater than 0. We'll throw this away because n has to be greater than 0, and that causes n, the number part in the log in the question, to be less than 0 because negative 1 minus 1 is negative 2, etc. So our only answer is x equals 4. That one doesn't violate any rules. Here's another example of an equation with more than one logarithm. Let us solve log base invisible 10 of the number 4 equals 1 plus log base invisible 10 of the number x minus 1. All right, and what we're going to do is gather the logs on one side so we can do the same trick we did in the previous video. So the solution is first gather logs, let's say on the left side, on the left. And anything that's not a log we'll leave on the right. So we'll subtract the log of x minus 1, and that will give us log base invisible 10 of the number 4 minus log base invisible 10 of the number x minus 1 equal sign 1. Now comes a step that's similar to the step 1 above. We just had to do that preliminary step first to gather all the logs on one side. Step 1, we're going to use laws of logs to combine the two logs. Once we get a single log, we can use the same method we used above. We can translate and solve. Okay, so it's rule number, what was that, 6? I can't remember. It's back in note 130. If you have log A minus log B, it's equal to a single log, base invisible 10, of the top 4 over the bottom, x minus 1. Bring down the equal sign, bring down the 1. Step 2, translate. I better write small so I can fit this all in here. Okay, using the butterfly, we have base 10, so it's 10 raised to the exponent 1 equals the number 4 over x minus 1. Okay, but we don't want a fraction, so let's multiply both sides by the LCD. We get 10 times x minus 1 equals the other side 4. Let's get rid of the fraction. Distribute multiplication. That gives us 10x minus 1 times 10 is 10 equals 4. And that implies, get the x term by itself. Add 10 to both sides, and it gives you 10x equals 14. And finally, get x by itself by dividing both sides by 10. X equals 14 divided by 10. And that implies, well, we can simplify. Factor a 2 out of the top and the bottom. It leaves x equals 7 over 5. Okay, so that's our answer, 7 over 5.